Hey yo, it's me, Factor and Frank, back showing you how to graph harder quadratic functions. Now here's a question. Why did the construction worker dip his finger into blue ink? Cause he needed a blueprint! Ow, ow, ow! Yeah!
Okay, first thing we're going to do is review a quadratic function. That's an equation of degree 2 written in the form y equals ax squared plus bx plus c. And you can see some examples of quadratic functions down here. They don't have to have a b and a c value. Like here, our b value is 0. Here, our c value is also 0. In this case, our b value is again 0, but our c value is -9. But each of these needs to have an a value that's not equal to 0 because you need to have that x squared term. Next thing we're going to do is review a parabola. That's the graph of a quadratic function written in the form y equals ax squared plus bx plus c. And here's the graph of y equals x squared. So if you plot all the points for y equals x squared, you get this U-shaped curve. Anytime you graph a quadratic function, so a function of degree 2, you're going to get a U-shaped curve. If your a is positive, it's going to open upward. If your a value is negative, it's going to open downward. Next thing is a vertex. So that's either the highest or lowest point on a parabola. If your a value is positive, your parabola will open upward, which means your vertex will be that lowest point. If your a value is negative, your parabola will open downward, meaning your vertex will be that highest point. Now, a minimum value of a function is the least possible y value for that function. So if we're talking about quadratic functions, it would be the y value of your vertex if your parabola opens upward. So here you can see this parabola continues upward forever. So it's not going to have a maximum, but this function will have a minimum, and it's going to be the y value of your vertex down here. In this case, -4. Now, the maximum value of a function is the greatest possible y value for that function. So you can see this parabola opens downward, meaning that it goes down forever, so it's not going to have a minimum value. But it will have a maximum value. And again, it's the y value of your vertex, which in this case would be 3. Now, the axis of symmetry is a line through a shape so that each side is a mirror image. In quadratic functions of the form y equals ax squared plus bx plus c, the axis of symmetry is found with the formula x equals -b over 2a. So real quick, an axis of symmetry, it's just a line that cuts a graph in half so that it's the same on both sides. In this case, when we're talking about quadratic functions, if you want to find the equation of the axis of symmetry, it's just x equals -b over 2a. So in this case, if you were to do x equals -b over 2a for your parabola here in red, you would end up getting x is equal to 3. And that's the vertical line, x equals 3, that cuts your parabola in half. Same thing over here. If you were to do that for your parabola in red, you'd end up getting x is equal to -5, which is a vertical line at x equals -5, which cuts your parabola in half. The standard form of a quadratic function we now know is y equals ax squared plus bx plus c, where a determines whether your parabola opens upward or downward. If a is positive, your parabola will open up. If a is negative, it will cause a reflection over the x-axis, meaning your parabola will open downward. Also, if your a value is really big, so bigger than 1 or less than -1, so let's say 100 or -100 or 2 or -2, your parabola will get stretched. It'll be really thin. Whereas if a is between -1 and 1, so like -0.5 or +0.5, something like that, your parabola will get compressed. It'll be a lot lower and flatter. Now, when we're talking about -b over 2a, remember that determines your x value of your vertex as well as your axis of symmetry. If you want to find the x value of your vertex because you're creating your t-table, which we're going to do in a little bit, you use the equation x equals -b over 2a. That'll also give you your axis of symmetry. And if you want the y value of your vertex, you just take that x value that you find with -b over 2a, plug it back into the function. Then c, last but not least, determines your y-intercept of your given function. In order to graph, your first step is to find the x value of vertex or axis of symmetry using x equals -b over 2a. Once you've done that, you're going to make a t-table with the x value in the middle. You choose 2 x values, 2 above that x value vertex and 2 below. Then you're going to plug those x values into the function and get their corresponding y values. Lastly, you're going to plot the points. Super easy.
Why couldn't the construction worker stay awake around the tunnel digging machine? Cause it was boring! Boom! Example time!
Okay, example 1 says graph the function y equals x squared minus 2x. So step 1 is to find the x value of your vertex or axis of symmetry using x equals -b over 2a. So in this case, let's name our a, b, and c. Well, this is the same as x squared minus 2x plus 0. So our a value is 1, our b value is negative 2, and our c value would be 0. So if we use our formula, we're going to take negative 2, plug it in for b. We take 1, plug it in for a. When we simplify this, a negative and a negative just make a positive, and you get 2 over 2, which simplifies to 1. This means that the x value of our vertex is 1. It also means that our axis of symmetry is at x equals 1. So at x equals 1, we put a vertical line so that we know that's where our axis of symmetry is. So when we graph our parabola, we should have the same mirror image on both sides of this axis of symmetry. So we move on to step 2, which is to make a t-table and put our x value of our vertex in the middle. We then pick 2 x values above that and 2 x values below that. We then take those x values and plug them into the original function to get the corresponding y values. So if I were to take 3 and plug it in up here, 3 squared is 9, minus 2 times 3 is 6, so 9 minus 6 is going to give you 3. Then 2, I plug in 2 for x, so 2 squared is 4 minus 2 times 2, that's also 4, so that becomes 0. I plug in 1, 1 squared is 1, minus 2 times 1 is going to be negative 1. Plug in 0, 0 squared is 0, minus 2 times 0, that's 0, so 0. And then I plug in negative 1 squared is going to be positive 1, minus 2 times negative 1 is also going to be positive, so it's going to be positive 2. So 1 plus 2 gives you 3. So now we can plot those points. 3, 3, we go over 3 on our x-axis, up 3 on our y-axis, put a point. 2, 0, we go over 2 on our x-axis, up or down 0, so just right there. And then 1, negative 1, we go over 1, down negative 1 on our y-axis, put a point. Then 0, 0, that's the origin. And negative 1, 3, negative 1 on our x-axis, up 3 on our y-axis, put a point, draw a parabola going through those points, and you have graphed your function. Also note, maybe you didn't see this last time, but if your points that you choose, your x values, are the same distance from your vertex point on either side, so this is 1 unit away, this is 2 units away. This is 1 unit away, this is 2 units away. Your y values should match for those. See that? Pretty cool.
Where does a raven go to drink? At a crowbar! Ha ha ha! You try.
Okay, doing the same thing. So step 1 is to find the x value of vertex or axis symmetry using x equals negative b over 2a. So let's figure out what our a, b, and c are. So in this case, a would be 1, our b would be 6, and our c, well, there isn't anything, so it's technically 0. So we got 1, 6, and 0. We then create our axis of symmetry formula. We plug in 6 for our b and 1 for our a. We then simplify this. 6 over 2 times 1, that's 2. So it's going to be negative 6 over 2, which is 3. So we got negative 3 as the x value of our vertex. It's also the axis of symmetry. So we can go over here to x equals negative 3, draw a vertical line at x equals negative 3, and we know that that is going to cut our parabola in half. It should be the same on both sides. Now, to create our t-table. We're going to put the x value of our vertex, negative 3, in the middle of that t-table. We're then going to pick 2 x values above that and 2 x values below that. We're then going to plug those into the original function to get the y values that go with them. So if I plug in negative 1 squared is positive 1, plus 6 times negative 1 is going to be negative 6. So 1 minus 6 gives you negative 5. Plug in negative 2. Negative 2 squared is going to be 4. And then 6 times negative 2 is going to be negative 12. So 4 minus 12 is going to give you negative 8. If I plug in negative 3 squared is going to be 9. Plus, and then 6 times negative 3 is going to be negative 18. So 9 minus 18, that's negative 9. Then negative 4. If you recall from what we talked about in example 1, since these are the same distance away, this should also be negative 8. And then this down here should also be negative 5. Let's see. If I plug in negative 4, negative 4 squared is going to be 16. Plus 6 times negative 4, that's negative 24. So 16 minus 24, that's negative 8. And if I plug in negative 5 squared is going to be 25. Plus 6 times negative 5, 6 times negative 5 is negative 30. So 25 minus 30, negative 5. Look at that. Perfect. So what we can then do is plot these points. Negative 1, negative 5. So we go over negative 1 on the x-axis, down negative 5 on the y-axis, put a point. Negative 2, negative 8. We go over negative 2 on the x-axis, down negative 8 on the y-axis, put a point. Negative 3, negative 9, over negative 3 on the x-axis, down negative 9 on the y-axis, put our vertex, there it is. Negative 4, negative 8, negative 4 on the x-axis, down negative 8 on the y-axis, put a point. And then negative 5, negative 5, over negative 5 on the x-axis, down negative 5 on the y-axis, and we put a point. Draw a parabola going through those, and you're done. Example 2, doing the same thing. So step 1, find the x value of vertex or axis symmetry using x equals negative b over 2a. In this case, we have everything. We have an a b, and a c. Perfect. We can then put those in our formula. We take 4, because that's our b value, plug it in for b. We take negative 1, because that's our a value, plug it in for a. Now we simplify. Since these are both negative, we're going to end up getting a positive, so it's going to be positive 4 over positive 2. So 4 over 2 simplifies to 2. That is the x value of vertex, is also the axis of symmetry. So you can go over to x equals 2, draw a vertical line, and that will be the line that cuts our parabola in half. So it should be the same on both sides. It's a way to check our work. We then create a t-table. Put the x value of vertex in the middle of our t-table. Pick 2 x values above that and 2 x values below that. We then plug in each of those x values to the original function to get the y values that go with them. Let's plug in 4. If I were to plug in 4 squared is going to be 16. Then you tack on this negative that's out front. Don't tack it on too early. So it's going to be 4 squared, that's 16, times this negative 1 is going to be negative 16. Then over here, 4 times 4, that's 16 also. So negative 16 plus 16 is going to be 0. Minus 1, negative 1. Plug in 3. 3 squared is 9. Tack on the negative, it becomes negative 9. Over here, 4 times 3 is going to be 12. So negative 9 plus 12 is going to be 3. You then subtract 1 and you get 2. Plug in 2. 2 squared is 4. Tack on the negative, it becomes negative 4. Then over here, 4 times 2 is going to give you 8. So negative 4 plus 8 is going to be positive 4. Minus 1 is 3. Then you plug in 1. 1 squared is going to be 1. Tack on the negative, negative 1. Over here, 4 times 1 is just 4. So negative 1 plus 4 is 3. Minus 1 is going to be 2. Lastly, plug in 0. 0 squared is 0 plus 4 times 0. That's also 0. And then minus 1 is negative 1. So notice, since these are the same distance from your vertex, that the y values match. We can then plot those points for negative 1. Over 4 on the x-axis, down negative 1 on the y-axis, put a point. 3, 2, you go over 3 on the x-axis, up 2 on the y-axis, put a point. Then 2, 3, over 2 on the x-axis, up 3 on the y-axis, put a point. 1, 2, over 1 on the x-axis, up 2 on the y-axis, put a point. And then 0, negative 1, over 0 on the x-axis, down 1 on the y-axis, put a point. Draw a parabola going through those, and you're done. Notice, because our a value was negative, that's why this parabola opens downward.
What's an astronaut's favorite tool? An orbital sander! Ha ha! You try.
Okay, here we go. Doing the same thing. So step 1, we want to find the x value of vertex. So here we have an a of negative 2, a b of 4, and a c of 3. We plug the a and the b into our axis symmetry formula. 4 goes in for b, and negative 2 goes in for a. We then simplify this. 4 over 2 times negative 2 is going to be negative 4, and this negative cancels out with that negative, so we end up just getting 4 over 4, which is 1. So x equals 1, we draw a vertical line. That's where our axis of symmetry is. That's going to cut our parabola in half. We then make a t-table. Put our x value of our vertex in the middle of that t-table. Choose 2 x values above that and 2 x values below that. We then plug those x values into the original function to get the y values that go with them. So if I plug in 3, 3 squared is 9, times negative 2 is negative 18. 4 times 3 would be 12. So negative 18 plus 12 is going to be negative 6. Plus 3 is going to be negative 3. If I plug in 2, 2 squared is 4, times negative 2 is negative 8. 4 times 2 is positive 8. So 8 plus negative 8, that just becomes 0. Plus 3, that's 3. Plug in 1. 1 squared is 1, times negative 2 is negative 2. 4 times 1 is 4. So 4 plus negative 2 is 2. Add 3, and that gives you 5. Then you plug in 0 for x. 0 squared is going to give you 0, times negative 2 is 0, plus 4 times 0 is 0, plus 3 is going to give you 3. And then negative 1. Negative 1 squared is going to be positive 1, times negative 2 is negative 2. Negative 1 times 4 is going to be negative 4. So you get negative 2 minus 4 is going to give you negative 6, plus 3 will give you negative 3. We then plot each of these points over here and draw a parabola going through them. So 3, negative 3 over 3 on the x-axis, down 3 on the y-axis, put a point. 2, 3 over 2 on the x-axis, up 3 on the y-axis, put a point. 1, 5 over 1 on the x-axis, up 5 on the y-axis, put a point. 0, 3 over 0 on the x-axis, up 3 on the y-axis, put a point. And then negative 1, negative 3 over negative 1 on the x-axis, down negative 3 on the y-axis, put a point. Draw a parabola going through those. Again, since our a value is negative, our parabola opens downward. Example 3, doing the same thing. So here, step 1, find the x value of vertex or axis symmetry using x equals negative b over 2a. Here we have an a b, and a c. A equals 3 halves, b equals negative 3, and c equals 2. So we're going to take those, plug them into our axis symmetry formula. So -3 goes in for B, and 3/2 goes in for A. We then simplify. 2 times 3/2 down here. 2 is the same as 2 over 1. So technically the 2's are going to cancel each other out. You just get 3 in your denominator. The negatives are going to cancel each other out. So you end up getting 3 over 3, which is just 1. Then, technically, that's your axis symmetry. So you go over here. At x equals 1, you draw a vertical line. That's going to be your axis symmetry. That's going to be a way to check your work. Your parabola should be the same on both sides of that axis of symmetry. Next, we're going to take that x value that we just got, plug it in the middle of our t-table. We're going to pick 2 x values above that and 2 x values below that. We're then going to plug those into the original function to get the y values that go with them. So if I plug in 3 squared is going to give you 9. You then multiply that to 3/2, so 9 over 1 times 3 over 2. You multiply the 9 and the 3, you get 27. Multiply the 1 and the 2, you get 2. So 27 over 2 is just 13.5. You then have minus 3 times, we're plugging in 3 for x, so that's going to be -9, so minus 9. So what is 13.5 minus 9? That's going to be 4.5. And then you add 2 to that, you get 6.5. So we plug in 2 now. 2 squared is 4. And then 4 times 3/2. 4 is the same as 4 over 1, so 4 times 3 gives you 12. 1 times 2 gives you 2. So 12 over 2, that's 6. Then minus 3 times 2. So that is also going to be 6. So 6 minus 6, that cancels each other out. That just gives you 0. Plus 2, that's 2. Now let's plug in 1. If I plug in 1 squared is 1 times 3/2 is just 3/2 or 1.5, 1.5. So this turns into 1.5. Minus 3 times 1 is going to be minus 3. So 1.5 minus 3 is negative 1.5. Plus 2 is just going to be 0.5. Then I plug in 0. Remember, since these are the same distance from x equals 1, these should match. So this should be 2, this should be 6.5. Let's check. If I plug in 0 here, 0 squared is 0 times 3/2 is 0. Minus 3 times 0, still 0. Plus 2, that's 2. And I plug in -1. -1 squared is +1 times 3/2 is 3/2, which I can rewrite as 1.5. Then over here, minus 3 times -1. So that's going to be plus 3. So 1.5 plus 3, that's going to be 4.5 plus 2, 6.5. Now I can plot these points. So here, 3, 6.5 over 3 on the x-axis, up 6.5 on the y-axis, put a point. 2, 2, I go over 2 on the x-axis, up 2 on the y-axis, put a point. Then 1, 0.5 over 1 on the x-axis, up 0.5 on the y-axis, put a point. 0, 2 over 0 on the x-axis, up 2 on the y-axis, put a point. -1, 6.5 over -1 on the x-axis, up 6.5 on the y-axis, put a point. Draw a parabola going through those, and you're done.
What's NASCAR's favorite tool? The screwdriver! Ayo! You try.
Okay, doing the same thing here. So first, what we want to do is find the x value of vertex or axis symmetry using x equals -b over 2a. So in this case, our a is 1/4, our b is -2, and our c is -1. So we use our axis symmetry formula. We plug in -2 for b. We plug in 1/4 for a. Now, 2 times 1/4, that's the same as 2 over 1 times 1 over 4, so that becomes 2 over 4, or 1/2. Now, the negative and negative just cancel each other out, and we end up getting 2 divided by 1/2, which is the same as 2 times the reciprocal, which is 2. So 2 times 2, that gives you 4. That means the x value of the vertex or axis symmetry is x equals 4. So we go over to x equals 4, draw a vertical line. That way we know that is our axis symmetry, and our parabola should be the same on both sides of that. Now we make a t-table. We plug that x value that we just got in the middle and pick 2 x values above that and 2 below that. We then plug those into the original function to get the y values that go with them. So here, if I plug in 6 squared, that's going to be 36 times 1/4. That's the same as dividing by 4. So 36 divided by 4, that's 9. Then minus 2 times 6. So -2 times 6, that's -12. So 9 minus 12 is going to give you -3. Minus 1, -4. Now let's plug in 5. 5 squared is going to be 25 times 1/4, or divided by 4 is going to be 6.25, or 6 1/4. You then subtract 2 times 5, so minus 10, that's going to give you -3.75, or -3 3/4. Minus 1 is going to be -4 3/4. I plug in 4. 4 squared is going to be 16 times 1/4, or divided by 4 is going to be 4. Then minus 2 times 4. So 4 minus 8, that's going to be -4. Minus 1 is -5. Let's plug in 3. 3 squared is 9 times 1/4, or divided by 4 is going to give you 2.25, or 2 1/4. Then minus 2 times 3, so -2 times 3, that's going to be -6. So 2.25 minus 6 is going to be 3.75 or negative 3 3/4. Minus 1 is going to be negative 4 3/4. Then lastly, I plug in 2. 2 squared is going to give me 4 times 1/4. That just cancels each other out. That gives you 1. And then minus 2 times 2, that's 4. So 1 minus 4 is negative 3. Minus 1 is negative 4. Now we plot each of these. So 6 comma negative 4, I go over 6 on the x-axis, down 4 on the y-axis, put a point. 5 comma negative 4 3/4, so I go over to 5 on the x-axis, down negative 4, and then 3/4, so almost to negative 5, put a point. Then 4 comma negative 5, I go over 4 on the x-axis, down negative 5 on the y-axis, put a point. 3 comma negative 4 3/4, I go over 3 on the x-axis, down negative 4, and then 3/4, so almost to negative 5, put a point. And then 2 comma negative 4, I go over 2 on the x-axis, down negative 4 on the y-axis, put a point. Draw a parabola going through those, and I'm done. Now, word problem says a baseball is thrown into the air with an upward velocity of 32 feet per second. Its height h in feet after t seconds is given by the function h equals negative 16t squared plus 32t plus 6. How long will it take the ball to reach its maximum height? What is the ball's maximum height? About what time does the ball hit the ground? So, step 1 of a word problem, we're not scared, we can do this. Step 2, what is it asking? It's asking us, how long will it take the ball to reach its maximum height? What is the ball's maximum height, and what time does the ball hit the ground? It's basically asking us to graph it, because from the graph, then we can see what the maximum height is and what time the ball hits the ground. So, let's graph it. If we were to graph this, step 1 would be to find the t value of your vertex or axis symmetry using t equals negative b over 2a, because t is our x in this case and h is our y in this case. So let's go ahead and do that. Our a value is going to be negative 16, our b value is going to be 32, and our c value is going to be 6. So we use our axis symmetry formula. We take 32, plug it in for b. We take negative 16, plug it in for a. So what's 2 times negative 16? That's negative 32. And what's negative 32 over negative 32? That's positive 1. So we just found the x value of our vertex, or t value of our vertex in this case. We also found the axis of symmetry. So we can go over to t equals 1, draw a vertical line, and we know that our parabola should be the same on both sides of that. Step 2, we're going to make a t-table with the t value that we just found in the middle of that t-table. We're going to pick 2 t values above and 2 t values below our vertex. We then plug those t values in to the original function to get the h values that go with them. So if I were to plug in 3 for t, 3 squared is going to give you 9, and then 9 times 16 is going to be 144, and that's going to be negative 144 because it's negative 16. We then go over here. 32 times 3 is going to give you 96, and then 96 we're then going to add to negative 144, and we end up getting negative 48. You then add 6, and you get negative 42. We go to 2. 2 squared is going to give you 4 times negative 16 is going to be negative 64. You then go over here. 32 times t is going to be 64 also. So negative 64 plus positive 64, those cancel each other out. Then you add 6, you get 6. And we plug in 1. 1 squared is going to be 1 times negative 16 is going to be negative 16. 32 times 1 is just 32. So negative 16 plus positive 32 is going to be positive 16. Plus 6 is going to be 22. I plug in 0. 0 squared is 0 times negative 16 is 0. Plus 32 times 0 is 0. Plus 6 is going to be 6. And then lastly, I plug in negative 1. Negative 1 squared is positive 1 times negative 16 is going to be negative 16. Then 32 times negative 1 is going to be negative 32. So negative 16 plus negative 32 is going to be negative 48. Plus 6 is going to be negative 42. We then plot our points. So let's start at the top. 3 comma negative 42. That's 3 on the t-axis, down 42. That's way off the graph. 2 comma 6. I go over 2 on our t-axis, up 6 on our h-axis, put a point. 1 comma 22 over 1 on our t-axis, up 22 on our h-axis, put a point. Then 0 comma 6 over 0 on our t-axis, up 6 on our h-axis, put a point. And then negative 1 comma negative 42. Well, technically, negative 1 as our t value, that's going back in time. So we don't even care about that, right? So we're going to just cancel that out. So we now have our points. We can draw a parabola going through those points, and we can answer our questions. How long will it take the ball to reach its maximum height? And what is the ball's maximum height? That would be the vertex up here, right? So the ball's maximum height looks like it's going to be 22 feet, and it reaches that after t equals 1 second. So we could say that the ball is going to take 1 second to reach its maximum height of 22 feet. Lastly, about what time does the ball hit the ground? Well, it looks like a little bit after 2. So the ball hits the ground about 2.1 or 2.2 seconds, somewhere in between there.